Hi there, I'm Mr. Sand, and this is polyatomic naming. So today we're going to talk about polyatomic ions. First, let's take a look at this chart right here. So this chart names all the common polyatomic ions. Now there are other polyatomic ions out there, but we don't cover them in this class. To know what polyatomic ions are before we go to this, we should define, or we should look at the word polyatomic. Poly meaning many, and atomic meaning atoms. So there's many atoms in these ions. And ions means a charged thing. So if you take a look at this chart, all of these are many atoms put together. They're strung together like a big chunk of atoms stuck together. They always move together. And they're charged. Overall, they're charged. So this polyatomic ion is charged negatively 1. This is another one that's a big chunk. It's C2H3O2, also known as acetate. That's negative 1 as well. All of these in this column right here are charged negative 1. Here in this column right here, they're charged negatively 2. And here, negative 3. And here, this is a weird one, positive 1. Okay. You will not need to memorize these, even though it is useful to know a couple of these just from memory. You'll always get this chart to solve any question. So, how do we do this? How do we use this chart to solve a problem like this, where you have a formula and you want to know what the name is? Formula to name. So I have to take a look at this myself. Let's say that we have Na, and just make it easy. Let's do H2PO4. H2PO4. Okay. We treat this entire chunk over here as one thing. We give it a name. And that name is, oh, you can make that small, that's nice. That name is dihydrogen phosphate. Okay, it's a long name, but it's the first one on this sheet, so I just use that. Dihydrogen phosphate. So, to name these polyatomic ions, all you have to do is write down the cation. In this case, it's going to be sodium. Write the full element out, and then what was that one again? There's dihydrogen phosphate. So this is the full name for this sucker right here. Okay. Now, just like any other kind of ion or ionic bond, you can have several of these things or several of these things over here. We can have several of the cations, which is the positively charged bit of the ionic bond, or you can have several of the anions, which are the negatively charged ones over here. So let's just suppose that you have, let's use calcium instead of sodium here. Calcium and then dihydrogen phosphate again, but this time there's two of them. And we'll get to that in just a second. But if it's like this, you don't need to say anything about this 2 over here. You just need to say calcium dihydrogen phosphate. So that's the full name. You don't need to say anything about that 2. Calcium dihydrogen phosphate. Perfect. Phosphate. Okay. So these are just chunks over here of atoms, big chunks, and they stick together always. And they have names. And when you name this entire formula right here, you're going to be just saying the cation first, which is the calcium, and then the anion, which is this big chunk over here, which is the polyatomic ion. And in this case, it's dihydrogen phosphate. Okay. Let's do the reverse. Let's go from naming to a formula. We'll write the formula from the name. So I need to take a look at this and the periodic table as well. So I'll take a look at this. Okay, I'm choosing right now. I'm going to choose, yeah, okay, and C2O4. Okay, got it. Now I'm going to write it over here. So I'm going to call this beryllium actually get the spelling right. I believe there's 2 R's. Nope, just 1 R, 2 L's. Beryllium. And then I'm going to use oxalate. Okay, beryllium oxalate. So it's pretty easy to start off here. You just say Be. Okay, I'm writing the formula over here. This is my practice area. I'm going to be writing it over here shortly. Be, and then oxalate. Well, we look up in the chart over here. Where's oxalate? Do you see oxalate anywhere? There it is. C2O4. C2O4, and it's negatively charged 2. C2O4. So I'll write down C2O4. Okay. Just like before, you do crisscross applesauce. So beryllium, we know that it normally gives 2 electrons. We know that because it's in the second group. It's got 2 valence electrons. We know that from the periodic table, and you always get the periodic table. And oxalate, well, that takes 2. Now, how do we know that? That's a tough one. How do we know that? Well, you take a look at this chart right over here. -2 charge means that it will take 2 electrons. -1 charge means that all these things over here will take 1 electron. -3 charge, these guys over here, they're going to take 3 electrons. And this over here, ammonium, is going to give 1 electron. So it acts like a cation. All right, so you know that oxalate takes 2 electrons. So let's go back over here, and we'll crisscross this. Crisscross applesauce. Okay, so it's going to be Be2C2O4, and that whole thing 2. But since these are the same number, we can just reduce it. We can just call each one of these 1. So it'll be BeC2O4, and that is our, all right, again over here, BeC2O4. That's beryllium oxalate. Okay, so that's how you go from a name into a formula. Let's do another problem real quick. Let's do the positive one. Let's do the ammonium one. So I'm going to say we've got a funky one here. I'm going to give you the name ammonium. Ammonium. Let's make this difficult. Ammonium sulfide. Okay, that'd be nasty smelling. Okay, ammonium sulfide. So what is ammonium? Ammonium, well, if you take a look over here, ammonium is NH4, and it gives away 1 electron. So NH4, and it gives 1. Sulfur is S, and we know that from the periodic table because it's right here. Sulfur. It's in this group, so it has 6 valence electrons. It's going to take 2 to get a full valence shell. So it's going to be taking 2. Takes 2. So if we crisscross this, crisscross applesauce, there'll be 2 of those and 1 of those. So it'll be NH4, but there'll be 2 of them. So put in parentheses. And then S, that's ammonium sulfide. Okay? Now you can do transition metals with this as well. So instead of the sodium being the cation, you just have a transition metal, and it would be named with the Roman numerals just like normal. So that, don't let that throw you, but those would be the most difficult kinds of questions you could run into. Okay? So this is naming polyatomic ions. I hope that made sense. Let me know if it didn't, and I'll talk to you soon.